We're going to be using our graphing calculator to explore what the different numbers do to our lines. So the buttons we're going to be using, first off, is the y equals. Can you locate that on your graphing calculator? Right here, y equals, right? So if you punch that in, you'll see that, right? Of course, mine's in color. Yours might not be. It depends on how fancy your calculator is. Okay, so that, to graph the line, our equation must be in y equals form. So hopefully you're good at being able to manipulate your equation, because that's a skill you'll need to actually use that. So to use the x, there is an x t theta n button. Okay, that will give you your x. So of course that is right here. Do you see? That will produce your x. It's not one of these x's, which is the green function there. You have to use this one right here, okay, for your x. All right. Then the window setting, if you don't have a good viewing window, you're going to use your window setting, and that will, depending on where your window is, mine's probably all wacky compared to yours. I'm going to get us to zoom to the same viewing window, and the same viewing window is the standard viewing window. So wait till we get to that. Again, everybody's is going to be all wonky, okay? But when we first do our first graph, I'm going to tell you to go to the zoom, and we're going to go to standard, number 6, and that will be the standard viewing window. So you can actually punch that in right now if you want. I have an equation. Remember, I had that y equals x in there already? Oh, that's because everybody, I guess, when you touched it. But do you see it's going 10 across and 10 up and 10 down, right? So that's the standard viewing window. So now if you look at my window, do you see it's going from -10 to 10? It's going up by 1s. The y is going from -10 to 10. It's also going up by 1s. And that was, again, where did I find that? Zoom 6, which is the standard viewing window. That will make your window settings. So if you ever graph something and you can't see it, you can use one of the zoom features to find it, or you can change your window settings, because if you know the graph is supposed to be on the left, you could change your x min. You know, say you know it's supposed to be, your x-intercept is supposed to be -15, and you can't see it, then you're not going to see it if your window only shows up to -10. Do you see what I'm saying? So you might have to change different things there. Okay. So, again, maybe I'll write this down. Zoom 6 is the standard viewing window. I would say every single time, redo at that point, and that goes from -10 to 10 for both your x and your y. Okay? So the next feature you're going to be using is the table. Because I have my y equals x already in there, if I go to my table, which is second graph, do you see it actually has a table of values? My table of values might look different than yours because my table is going up by different amounts. So if I want to change how much my table is going up by, what I do is I need to go to not the window, but the table set, which is second window. And you see, I have my window starting, or my table starting at negative. It's just because I had something from my previous class in there. So you probably want to just start it at 0 and go up by 1s, right? So that's probably more what you've seen in grade 9, is a table of values that looks something like that, right? With whole numbers, nice little things like that, right? I'll put that in the notes here. So that is table set TBL, or second window. And that allows you to choose the starting, that should be starting X value and the scale it goes by. So I changed it to, I changed it so that it would table start, TBL start. I changed it to 0, and then the change of the table was, I changed it to 1. It depends on the question what you want it to go up by. Like for instance, if you know you have a discrete data and you know you're going up by 12s each time, then you could have this, so each number goes up by 12, right? So, and then of course, putting graph shows the graph. So going here and just putting graph, there it is. Right. Of course, I had y equals x in there. That's why it's showing y equals x. Okay. Any questions so far? So it's kind of just going over some of the features of your calculator. Okay. So, and if you want to get out of this, you go second quit, right? And then you're back to your normal functioning part of your calculator, right? So if an error occurs, so all these things happen all the time. It's like, my graph doesn't, blah, 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 blah. Okay, so have this page ready to go. So if an error occurs, remember to check, this is your window settings, right? Okay, so remember to check your window settings if you ever get an error to occur. Because say you're trying to calculate something and you're trying to find your x-intercept, and the x-intercept happens to be -15, say. Well, if you can't see -15 in your x-axis, it can't calculate it. It'll give you an error, okay? So calculator is good, but it's not that good. Okay, so here's the other thing. If you have your stat plot on, it gives you an error when you're trying to do the graphing features. So to check to see if your stat plot is on, do you remember how to go to your stat plot? Remember your stat plot? You see your stat plot right here, second y equals? Make sure they're all off, right? And so I think if you press 4, it'll turn everything off. Is that right? Let's try it. And then go enter. And they're all off. I think that's a new feature. I don't know. 4, then it turns all of them off. So I would say just make sure, like now that you have them off, unless you do a data thing, it should never turn it back on, right? Okay? So enter 4. 4, enter. That stat plots off. So here's another thing that people get totally wrong all the time. There is a difference between, this is the subtraction button, and that's the one that's above your plus sign. And then this is the minus sign, meaning it's a negative number or something, and that's beside the enter key. If you use, for instance, if you want to calculate -2 plus 5 and use subtract 2 plus 5, it'll give you an error. Same with when you put it into the actual equation. If it's a negative slope and you type in y equals -3/5 x plus 2 and you use the subtract button instead of the negative button, it'll give you an error. Okay, so that's usually where students make their errors on. Okay, so now the next button you need to know is check the formatting, which is second zoom. Okay, and let me just go to that on here. And sometimes you have something goofy going on there. Like I know I have a few things listed here. But a lot of the times, if you've been screwing around with your calculator or you lent it to somebody and they did something in, I don't know, physics class, you may want, when you get it back, just to reset your defaults. I'll show you how to do that. You go to second plus. You see there's your memory button. And so if you want to reset your defaults, that's number 7. Okay? And then you can reset all your defaults, which is number 2. Okay? So if something's really screwy, like you've tried everything under the book, your last step is to reset everything and start all over. Now, the only thing about that is, for instance, in trig, you guys have your mode right now probably on degrees. If you reset it, it'll go back to radians, which is something you use in grade 12. That's why mine is on radians right now. But there's little things that it'll reset it back whenever you change it. So I would say that's probably a last step if you need to. But does everybody remember how to do this again? Second, memory. Then you go to number 7. And you reset the defaults, and then you press number 2. I'm not going to do that because I don't want to screw anything up I just did. Okay. So I'm going to clear this. So now we're going to type this into our graphing calculator. So do you remember how to graph or type this in? Y equals x plus 2. So where do we go to do that? We go to y equals. Now, if I have something already there, I would say press clear to clear it, then start all over again. And so what was my equation again? X plus 2. So x is right here, plus 2. And so that we're all on the same viewing window. After I do this, I'm going to go zoom. What was it? 6 for the standard viewing window. And there it is. Except I forgot 2 buttons at the bottom. I guess I didn't scroll down enough. So this arrow button, that's the arrow up button, arrow side. It'll let you take the cursor and move it. And then the zoom button. I want to show you something just so you know how to use the zoom in and zoom out button, because some people don't understand how to do that. So if we go to here, does everybody have this line that we just did, x plus 2? So I want to show you how to zoom in, because you'd think it'd be, you know, pretty user friendly, but okay. So you select zoom in, so which would be number 2. That doesn't mean it zooms in right away. Do you see where this cursor is clicking off and on like that? If you press enter where it is right now, it'll zoom in to that spot right there. So if you want to use your arrow up or arrow down, for instance, say I want to look where it crosses the y-axis more, I take my cursor and put it up to say there, and then press enter. It'll zoom in way more into that spot. Okay? So try your zoom in. Sometimes, again, if you're trying to calculate something and you can't see the window well enough, that's where you would zoom out, which is zoom 3. Again, if you want to zoom out in that spot, press enter where you want to zoom out. This is back to normal. I want to zoom out again. Do you see? If I want to zoom out in that spot, it really zooms out, right? And then how do I want to get back to the normal zooming window again? Zoom 6. So zoom 6. And then we're back to their normal zooming. Okay, so it does say to do a rough sketch at this. I'm lucky enough I can, oh, shoot. Let me just go delete. I want you to do, whoops. Okay, so now I want you to take this and do a quick sketch so you know what this looks like. So I am lucky enough I can just copy and paste this. But I want you to do a quick sketch there of what it looks like. Okay, so for the next equation, what's the problem with the next equation here in order to put this into our calculator? Huh? What's wrong with this? It's not solved for y. So we can't put it into my equation that way. So how do I do that? Yeah, we got to solve for it. So that means I need to get this y by itself on the left-hand side. So how would I do that? Algebra. So algebra says whatever you do one side, you do the other. So we need to get rid of what first? No, we do not divide by 2 first. You need to get rid of the minus 10x. How do we do that? Add 10x to get it over to the other side. So that would cancel that. Now I have 2y equals 10x plus 10. Any questions how I got that? I cannot add 10x and 10 together, so I just kind of smoosh them together and write them like that, right? So now to get y by itself, I have to get rid of the 2. How do I do that? Divide by 2 to both sides. Okay? Y equals, what is 10x divided by 2? 5x. What is 10 divided by 2? 5. Does everybody see the 2 is dividing both the 10 and this 10? You learned that in grade 9, right? So now we're going to put this into our calculator, 5x plus 5. So where do I go for that? Y equals. I don't want this equation still on there. Sometimes I do, and then I go to y2, but I don't want it. So now I'm going to just go clear, and I'm going to go 5x plus 5. Graph. Zoom 6 should be still in there because you didn't change it, right? So do a rough sketch on here. Okay, so do a rough sketch there. Okay, what do we have to do for the next one here? This is not solve for y, so what do we have to do first? Solve for y by doing what? Algebra. So what do I have to do first in algebra? Is this 5x times minus y? No. How do I get rid of 5x? Subtract 5x. So then I'm left with, watch, there's a negative with the y, right? Negative y equals negative 5x minus 11. Has anybody ever showed you a trick, if you're ever left with a negative y, how to get what positive y is? Yes? Well, you can divide by negative 1, but what's the trick? Just change them all, yeah. Algebra 101 says whatever you do to one side, you do the other. So if you change the sign on the left side, change the signs on the right side. And it's exactly what you're saying. You're essentially dividing by negative 1. So y equals 5x plus 11. So now we're going to put that in our calculator. Yes? Y equals, clear it, 5x plus 11. Graph. Everybody see that? Do a quick sketch. Yes? All right. So now I'm going to show you how to calculate your y-intercepts on your graphing calculator. Who can tell me how to find your y-intercepts? Okay, last unit we learned how to find the y-intercept. Who can tell me how algebraically? I'm not talking about on their graphing calculator. Algebraically, how do we find our y-intercepts? Yeah. Okay, so recall the y-intercept. What do I want in that little bracket there? I guess y. Is found algebraically by letting x equal 0 and solving for your y value. On your graphing calculator, we're going to use the feature called calculate, which is second trace. So we're going to leave that number that was, you guys still have this on your graph? Because we can't calculate anything if we don't have anything on there. So we're going to use that. Okay, so we're going to try this. So we're going to go to second calculate. Does everybody see we have this feature called value? So if I type value in, it says, give me what x value you want me to calculate. So for instance, if I want to know what the y value is when x is, say, 2, well, I can't read it. Let's say when x is 1, I type in 1, enter. Do you see it finds that y is 16? Yes? So if I want the y-intercept, I go to calculate, value, and remember algebraically, my y-intercept is when x is 0, so I say x is 0, calculate it. Guess what it is? 11. Okay? Yes? Okay, now to find your x-intercepts on your graphing calculator, they are actually called something on your calculate. They're called zeros. In grade 11, we will learn that x-intercepts are called zeros. They're also called roots. On your graphing calculator, they're called zeros. So, again, algebraically, how do I find my x-intercepts? Yeah, I let y to be 0, and you solve for your x. So again, we go to calculate, which is second trace, and we type 0. Okay, I want everybody to try this because it's a little bit more complicated here. So number 2 is 0. Then do you see it actually says left bound here? So on a line, we would have a maximum of 1 x-intercept. But when you get into higher level maths, we might have a function that goes like crazy. And you might have about 5 x-intercepts. So the calculator is asking you, like, where do you want me to calculate this x-intercept? So left bound means is you need to put the cursor on the left of the x-intercept you want it to calculate. So I'm going to use, so it tells you right now mine was at x equals 0 to 11. So I'm going to go press my left arrow button until I get on the left of the x-intercept. Doesn't matter where, it has to be on the left side of it. So here's my x-intercept. Does everybody see that? I just have to be on the left of it. So then I press enter. Okay? Then it says, what about the right side? So that means you now have to go on the right side of the x-intercept. As long as I'm on the right side, then press enter. So do you see it? Now it has these 2 lines here, and it's saying, I'm going to calculate where the x-intercept in this basically range right here. And for some goopy reason, it asks you, do you want to guess? No, I want to calculate it. Just press enter. Who cares over the guess? And then it just tells you, your 0 is negative 2.2. Is that what everybody got? Yeah. Okay. So that's all that stuff. So I want you to now try this A and B on your own, and then we're going to go over it. So what you're going to do on your graphing calculator, you need to find the y-intercept on the x-intercept. So you need to graph this first, then calculate your x-intercept and y-intercept. Once you've done that, then go to B. You can't do them all at once, okay? Okay, so did you get your x-intercept to be -1 and your y-intercept to be +1 for the first one? Okay, are we having trouble solving for y? Let's make sure we're solving for y correctly. So we got to get rid of the 2x first, so subtract 2x. Yes? So then you get -3y equals -2x plus 8. Everybody good with what I did? Now I'm going to divide by -3 to both sides. So I get y equals, what do I get when I have -2x divided by -3? I get 2 over 3. It's a fraction, right? So 2 over 3x, and what do I get over here when I have +8 divided by -3? Yeah, I get -8 over 3, a fraction. Who cares? It's just a fraction. Now solve what your x and your y-intercept is, okay? So did you get your x-intercept to be 4? And your y-intercept to be -2.6 repeating? Is that correct? How I did what? Now we're going to do a bunch of graphs on the same. Do you see what I'm doing here? Yes? Okay, so we're graphing y equals mx plus 6. Guess what m stands for? Slope. Does everybody see that the negative 2 is my m, the negative 1 is my m? Yes? It's giving you all of that for you. So we're gonna actually put these first two into the same graph. So is this a subtract button for negative 2? No, that's the minus one. So let's go here. Y equals, clear it, negative 2x plus 6. Okay, I have blue, so I'm going to be able to tell mine from the second one because my second one is red. Some of you guys have some basic calculators here and don't have color. I will show you how to change it so that you can distinguish between the two lines, okay? So let's go to the second one. What was the second one? Negative x plus 6. Everybody got that? Okay, so I'm going to show you how to change this. So if you go up and you go to the left past y2, do you see that? It's flashing right there. Okay, if I press enter, mine's going to look different, but if you press enter on the basic calculators, it'll make it thicker when you press enter. And if you keep on pressing enter, it'll go to dashed and dotted and all that stuff. The people with color ones don't change it because it's good, right? Yeah. Like I said, mine is a different looking thing. You can change this so it is shading and all this stuff, dashed, all this good stuff, dotted. But we just want it regular. Okay. So, oops. Okay, so now I'm going to put, look what it looks like. There's the two things, right? You have to press both equations in.
Oh, I deleted the other one.
Do you see I have two equations? That's why I have two lines. You got to have two equations to have two lines, right? Okay, so remember my blue one was the first one. Yes? My red one was my second one. Okay? Does everybody see that in my blue one, it gives you the answers there, that the slope of the graph is negative 2? How could I tell that it's negative 2? I'm just going to put this on my smart notebook. Let's see here. Does everybody see? How can I tell that my slope is negative 2? Well, look. I can go down 6 over 3. Do you see? Down 6 over 3. Do you see I get a slope of negative 2? Yes? Does everybody see that my x-intercept is 3, my y-intercept is 6? Yes? If I want to find the x-intercept of the red, again, I got to jump up to the red, so I'm now, my cursor's on the red. I got to narrow it down to where that x-intercept is. So get close. Whoops. It's off my thing here. There we go. Oh, shoot. I have to go on to calculate my zero. Sorry. Calculate my 0. I got to jump to the red. There, I got to get close. Press enter. Go on the other side of that x-intercept. Doesn't matter where you stop. Press enter. Do you see my x-intercept has to be between these two lines in order to calculate it. So then I press enter past the guess. Do you see my 0 is 6 for my red line? Okay. So my x-intercept was 6 for the red line. What else do we have to find out from that? Oh, yeah, my x-intercept was 6, sorry. Yep. It's also my y-intercept though too. Do you see they both cross at 6 there? So that's still 6, right? What's my slope here? So if you can't tell, if you know this is 6, you're going down 6 over 6. So what is that? It's -1, and you know it's negative because down to the right. Okay. So I'm going to get rid of this part right here. Okay. Okay. So I'm going to get rid of this. How can you use your graphing calculator now to do, not a quick sketch now, a real sketch? You guys know this from the last unit. If you have your x-intercepts and y-intercepts, you put those two dots and connect the line, right? So if I know my x-intercept is 6 for my red line, actually I should use red. For my red, here is 6. Here is my y-intercept. Now I'm going to connect the dots. It's not a rough sketch anymore. We're doing exact. You're going to take a ruler, connect the dots, right? Okay, everybody see? There's my other one. And what are we supposed to have on these lines, by the way, again? Arrowheads, yeah. So we're going to put arrowheads. And I'm going to actually, I want you to, if you have more than one line on a graph, you need to label which one's which. So what was this one that was already pre-drawn? That was the y equals -2x plus 6. And this one right here is y equals -x plus 6. Okay, so I want you to now do the rest of this page. By the way, can you see anything, any kind of patterns going on with the numbers versus what you have there? Yeah. Does everybody see? That is that, right? That is that number, right? So what do you think you're... Okay, so I'm going to, so you'll start discovering things. So I want you to do the rest of the page. I'll give you like about a minute or so to do it. Okay. So you should have a horizontal line going like this, yes? Yeah. Your slope is 0. What does that first one stand for? X-intercept. You can see visually it doesn't cross the x-axis. So what do you write? No, 0 means it crosses at 0. So you cannot write 0. You could say NA, but that's not really a math term. We'll just say there is none. None. But you gotta put something. So if I say list the x-intercept, you have to say none. Okay? I guess I would accept NA, but whatever. And of course my y-intercept was 6. Yes? Okay. The next one. The slope was 1. The slope was 2. The x-intercept was, for this one, -6. And the x-intercept for this one was -3. Yes? And 6. So I'm going to do the first one. I have a -6 and a +6. And I'm going to connect the dots there. Yes? And then I have a -3 and a +6, and I'm going to connect the dots. There we go. And we put arrows on it, right? And what else do? We label it when there's more than one on there, so I know which one is which, right? So this one is y equals x plus 6. This one is y equals 2x plus 6. Has anybody discovered anything about, there's a pattern. What's the other pattern besides? Yeah, does everybody, they all go through 6s. What do you notice about the equation? They all have 6s right here. Guess what this spot stands for? The y-intercept. So the first number here that's multiplied by the x, what was that again? Your slope. The number that's added to the x after, what is that again? Your y-intercept. Very good. Okay, so can you tell me from part A, what is my m? -3. What's my slope? Same thing, -3. You can't tell your x-intercept by just looking at it, but you can tell your y-intercept by just looking at it. What is it? 6. How can I find my x-intercept without the graphing calculator? I will repeat. How do I find my x-intercept without the graphing calculator? You set y to 0. So 0 equals -3x plus 6. We do algebra to solve it. Move the 6 over, it becomes -6 equals -3x. Divide by -3, we get x equals 2. So that means my x-intercept is 2. So this is how we were graphing before. We took our x-intercept is 2. My y-intercept is 6. And we connected the dots. Yes? Yes? Okay, I'm going to show you a brand new way to graph on top of this, okay? Everybody's, oops. I'll give you a second to, okay, so everybody see how I got that line so fast? I graphed the x-intercept, y-intercept, connected it. Okay, I'm going to show you another way you can graph as well. Some of you might have learned this in grade 9 if your teacher showed you this little trick. Okay? Your y-intercept physically, I'm going to use a different color right here, is that. Do you remember the question the other day where I gave you a point and a slope and you had to figure out where the new point would be? Guess what? If you start at the y-intercept and your slope is -3, what does -3 actually mean? So first off, I need to have it in rise over run form. So -3 is not in that form. So how can I make it in that form? Yeah, -3 over 1. Everybody see that's still the same? So if I take this 6 and I go down 3, 1, 2, 3 over 1, guess where my next point is? On the line. So that's a quick way of graphing. You take your y-intercept, use your slope, get your second point, connect the dots so that you don't have to solve for the x-intercept. Faster. You don't have to do this extra step here in finding the x-intercept. So let's try this one. We're not going to find the x-intercept right now. We're going to do it using the fast way. What's my slope? 3. How do I make my slope into rise over run form? 3 over 1. What's my y-intercept? 6. So what do? I put a point on 6. Now what happens if I go up 3 over 1? I'm off the graph. Can anybody tell me another way to write this slope instead of, okay, if I go left, what would I have to do to the top then? Okay, why would I change a slope of 3 to -1 over 3? That would make it perpendicular, right? Okay, so +3 over +1 is the same thing as -3 over -1. Remember I said I do not like going to the left unless I'm forced. This is a situation where I'm forced. So I'm going to go down 3, 1, 2. So I'm going down 3. I'm going to use a different color pen here. Okay. Down 3, 1, 2, 3, left 1. Do you see there's my other point? Do you see it's still going to make a positive slope? Yes? And then I connect the dots. Yes? How fast is that graphing? Pretty fast, eh? And guess what? Now I can read my x-intercept. What's my x-intercept? -2. Okay, so how does changing the value of m change the line? When m is positive, the line goes up to the right. When it's negative, it goes down to the right. What does the m represent? Slope. And what did we discover slope was the same as? from the other unit? ROC, rate of change. Yes, rate of change. Okay. So we're going to do this fast. No graphing calculator, right? Okay. No graphing calculator. So what graph did I graph here? What does the 2 represent again? The slope. What does the -4 represent? We're calling it B, but that's your y-intercept, yes? So a point on -4, and how do I make 2 a rise over run form? 2 over 1, yes? So I'm going up 2 over 1. Do you see how they got that line? So we're going to do it the same way. A point on -2, and then what's the slope there? It's still 2. So I'm going up 2 over 1. Do you see? Take my ruler, connect the dots. I need to extend it so it's not short, stubby lines. Okay? And what do these lines look like to you? Parallel. Did you know that they were going to be parallel? You should have. How do I know they should have been parallel lines? They had the same slope, yeah. So this first one was y equals 2x minus 4. This one is y equals 2x minus 2. How is 2x minus 0 going to work? Oh, shoot, we're not going to finish this. We may have to finish this lesson on Monday here. Yeah, it's huge, hey? I know.